Alright, this is what I'm going to do from Mount Baker to Blue Mountain in Washington. So, here's this guy that did it, and I'm going to replicate what he did.
Here's Mount Baker, viewed from about 6,000 foot elevation, at a distance pretty far away. And the angle is positive 0.058 degrees up from eye level. And I am right on the peak of Blue Mountain above Port Angeles. There is the summit spike, surveyor's spike there. It's beautiful up here today. That's Mount Baker right there.
Alright. So, the way I do it is through good old Earth-centered, Earth-fixed coordinates. The satellites use this. It's pretty much X, Y, Z coordinates. That's a diagram of it. Origin point 0, 0, 0. Center of mass of the Earth. So that's how it works. I use this program XYZ win, and then I put Latin long to XYZ. So I put my Latin long, which I already know, and then my ellipsoid height. I can just put the elevation. I mean, I really don't. You get your elevation and then subtract it from your geoid height, and then you come up with your ellipsoid height. But I didn't really have. I do have one of the marks from NGS, but I didn't have the Blue Mountain one. So the NGS for Mount Baker, which I do have, and it tells me right here the position, which is 47 degrees, 57 minutes, and 17 seconds north, 123 degrees, 15 seconds, and 34 minutes west. And the ortho height, which is the ground elevation, right there, so 610 feet. The geoid height is right there, negative 19. That's in meters. So I would subtract 1832 from 19.75, and that would give me the ellipsoid height. But I can just use this number, and it's good enough. So I created my text file like this. So that's what I got through this program. That's the numbers that spit out. And then I just make another point, just a negative. So I have 2 points so I can draw a line, and then I did the same thing for the other one. So that's my text file to load into AutoCAD. So, and this is in meters. So if I can find the So I have the ellipsoid and the perfect circle, both of them. So that's in feet and that's in meters. So that's the horizontal radius, and then I have the vertical. Anyway, so if I turn on the rendered view, and so you see the red and blue. I think can't remember. So the blue is the ellipsoid. It should be like all red. And then here it should be like blue, because it's wider. Anyways, here we are with those 2 points, and they stick out like little needles. There's Mount Baker and Blue Mountain. So basically this is the equator line, and this is the prime meridian. Oops. That line there is a circle. And so when I get those points in, then I project that line top of the mountain straight down to the equator, and then rotate that to that point, and then do the same thing for the other one. And so I'll show you the latitude. So if I go 3 point, measure it. Probably be upside down. So 47 degrees and 57 minutes. Okay. And so then staying here, position 47:57. Okay. Now I can do it the other way too, from the latitude or longitude. So we'll go 3 point again from here to the center to here and measure. And I get 123 degrees and 15 minutes. Okay, and that says 123 and 15. So we know we're in the right position. And I know that based on this triangle. So, if I orbit it, you can see it's all in the same plane. Alright, so I'm trying to find out what he got. Okay, so let's reset this thing real quick. So I need to find the horizontal tangent line from this point. And the reason why this point, when I extend that down, it will not hit to the center of the earth because, like it said, it's or was a center point given. It's center earth position. It's not rotate. It's the center of the mass of Earth. So that's why it doesn't hit the center of the Earth, because the center is not the center of the mass of Earth. So, anyways. So, we'll go 3-point. NEA from here to here, and then back down. And I'll draw 2 lines, because I can't tell which one's a right angle to that point. So I'll just draw a line this way. And I'll draw one this way. And then I'll rotate it. Okay. See how it's 90? So we know it's not that one. So I erase it. Okay, back to my view. 3-point. NEA. Oops, NEA. To here. And I don't want the front, I want the bottom. So it puts it into that view head on. So there's Mount Baker. So I'm striking a line 90 degrees to that point, which I already have. Okay, so I measure it. So it's above the mountain. Okay, so let's see what I get. He got 0.05. Okay. And so I got 0 degrees in 5 minutes. And so that's pretty much what he got. Let's play it one more time.
Here's Mount Baker, viewed from about 6,000 foot elevation, at a distance pretty far away. And the angle is positive 0.058 degrees up from eye level. And I am right on the peak of Blue Mountain above Port Angeles. There is the summit spike, surveyor's spike there. It's beautiful up here today. That's Mount Baker right there.
Yeah, right there. So he said up. So I got the same thing. Get rid of that. So, check one more time. So we got the distance between the two. I could draw an arc, but it's not really going to amount for much. So it's in meters. So let's transfer this number to miles. So meters to miles. So I got 87.49, right? Back to Google Earth, measure miles. Zoom in here. Pretty tall mountain. So I got 87. I got two the mat length and ground length. So 87, well, if you just round it to the 10th, it's 5. So 87.5. And I got, if I round mine, 87.5. Pretty cool. So, I guess I can check the other angle. We'll check the latitude for Blue Mountain. So 3-point. NEA from the equator, center of mass, and then midpoint of that, just on that line, and then we'll measure it, the angle. So I got 48 degrees and 47 minutes north latitude. So Google Earth, because I don't have an NGS deal. And so down at the right hand corner, I got what did I get? 48, 47. Okay, so 48, 46, 47 right there, 48, 47. So I'm in the right location. You tilt this thing, maybe. Oh. Well, actually, this tells me. So my properties. So if I round that 48, that 6 would become a 7. So 48, 47. 48, 47. Alright, well, why not do the longitude. Point. We'll go from here. This will go to the center of the Earth, to the prime meridian. Measure. And I got 129 or 121.49. Okay. So on that, I got 121.49 would be, well, it don't matter if you round it. Same thing in the lower right hand corner. So it's pretty cool. See how it's more red here? And then it's blue at the equator. That's the difference between because I have two different solids in here. So it's why it's like because of the bulge. It should be red. And then it should be blue at the equator. Well, South Pole too, but so, well, that's it.